Let's get froggy. Chainlink is a technology that allows smart contracts to have access to off-chain information in a decentralized way. It's also known as Oracle technology. Most blockchain industries today, like DeFi, rely on Chainlink for their services to work. And it's how I wound up with this NFT tattoo right below my eye. Today, if you want data in your smart contract, you'd either use a Chainlink data feed or Chainlink any API. Chainlink data feeds are well-oiled, decentralized Oracle networks. They have multiple nodes getting data from multiple sources, aggregating the data off-chain to save gas, and delivering the data on-chain in a single transaction. This architecture of aggregating the data off-chain is called off-chain reporting, or OCR. And it is just, wow, gorgeous. With this, we never have a single actor, be it a single node or a single data provider, that can manipulate the final result. Malicious nodes get kicked off these dons, malicious data providers get swapped out for new ones, and honest Chainlink nodes get paid out in Chainlink token to incentivize them to keep being good. Well, this sounds awesome. The issue, my friend, is that setting this up takes a long time. You have to get the node operator to add jobs for the data. It only works with numerical data, and it's hard to request updates. It works perfectly for what it does, but if you want to bring in custom data, it can be very difficult for the effort to be worth it. So, how can you get custom data then? To learn how to get custom data, we need to go all the way back to the dinosaur ages before OCR, to the year 2019. Back then, all the node operators had a generic job called a get job. And in your smart contract, you just need to identify the Chainlink node you want to call, identify the HTTP GET URL you wanted, and identify what part of the API response you want it to be delivered on chain. And with this setup, you'd be able to get any data you wanted. The code looked something like this, and it was much easier for an average developer to set up. Let's put these two architectures side by side though. Do you see the difference? With this any API setup, we'd have a single node and a single data provider. Centralized alert, centralized alert. So as a developer, it was on you to select many node operators with this method, find many data providers, and have them aggregate the data on chain. You can do this, it still takes a lot more work, but now if we put these two architectures side by side, you can still see another issue. Data feeds have the advantage of doing the aggregation off chain, which is much cheaper gas-wise. Any API with multiple nodes has to do this data aggregation on chain, which can be 10 times more gas expensive. This version of Chainlink still exists, and it's called the any API version. And a lot of people still use this to build a demo of what they want to build in the future. I've been a judge at many hackathons, including many Chainlink hackathons, and I've seen thousands of these projects come through, and they are all super cool, but really hard to build a sustainable protocol out of these. And this all ties back to why I'm so excited for Chainlink Functions. This is what Chainlink Functions, which was just dropped, does. It takes the Chainlink any API architecture from this to this. We have price feeds. We've got these dons that are already set up. Chainlink Functions moves having to request a single Chainlink node for arbitrary data to requesting an entire don for arbitrary data. Meaning you skip the step of having to coordinate with other node operators. You save gas because your data is aggregated off chain and the nodes are already decentralized. Now, the only lift on your end is going to be making sure the data is sufficiently decentralized because the architecture is already done. But wait, there's more. You can now also run arbitrary code on the Chainlink nodes. Yes, that's right. You not only just can do HTTP GET requests, but in the beta release, you can run JavaScript code on the Chainlink node. This fixes having to create different external adapters, which I'm not going to go into. If you've been in the Chainlink ecosystem, you know what those are. Now, what does this all mean? It means getting arbitrary data in a decentralized context has just been massively reduced in complexity. It means all these projects that I've seen from all these hackathons have a chance to go production much easier, much quicker. It means the age of the decentralized cloud is upon us. Connect your smart contract to your Tesla. Connect your smart contract to a sports result. Connect your smart contract to your cat. Connect your smart contract to anything you want, because now you can finally do it in a much easier manner. Now, we're going to finish this video by showing you the beta of how to get started. Keep in mind, depending on when you watch this next section might totally get revamped. So be sure to use the link in the description to go to the docs to see the most up-to-date docs. But I'm going to give you a demo of how it works, how you can work with it, and how to get started. Let's get froggy. Like I said, be sure to use the documentation in the description for this. But to get started, we're going to go ahead and clone the Functions Hardhat Starter Kit. This is going to be a minimal hardhat project with all the Chainlink functions built in. You can scroll down to the README to get started. As you work with this and as you build with this, make sure to make issues on this GitHub repository or any other place that this repo says, so that you can lead feedback to make this even better. Once we have it cloned, we're going to run npm install to install the dependencies. Then you want to set your environment variables. You'll need a private key And if you want to work with this on a testnet, either use a Mumbai RPC URL or Sepolia RPC URL, as well as an Etherscan and Polygon API key. If we go to our functions consumer.sol and scroll down, we can see the main function that we're going to be running is this execute request. This is going to take a string call data source. This string is going to be JavaScript code that we're going to run. Secrets is going to be encrypted passwords that we might need for our source. Ignore secrets locations. For now, args is going to be arguments we're going to pass into our JavaScript code. Subscription ID is our ID for our connection to a DON, and then a gas limit is a gas limit. And this Solidity code is the Solidity code that's in charge of executing our JavaScript code on the Chainlink DON. Go to calculation example. This is going to be the JavaScript code that we run on the DON. You can see that this is doing some real basic math, and that's all that this is doing. But we could write our JavaScript code to do anything that we wanted, including making HTTP GET requests. Making HTTP GET requests does require a little bit more setup, so be sure to read the docs to learn how to do that. We can simulate this JavaScript code by pulling up our terminal and running npx hardhat functions simulate. There's a hard hat task built in here called functions simulate that we can do to run our JavaScript code as if it was on a node. So we can run npx hardhat functions simulate. It'll first compile our contracts and then give us an output saying our JavaScript returned this number. We can go back here and make this even easier, just to sanity check it and just say, okay, let's just have it do 777. Now let's simulate it. And we see that on chain, we would get the number 777. Additionally, built in to the starter kit, there's a functions deploy client, and we can deploy to the Mumbai testnet. So I'm going to copy paste this. And this will deploy our functions consumer to the actual testnet so we can simulate testing this on chain. You can see we now have a contract deployed to the Mumbai testnet, and it's already been verified. If we don't already have a subscription with the Chainlink DON, we're going to go ahead and use this command to create a Chainlink subscription. We're going to use our contract deployed address, and we can fund it with just one link. And this is going to create our subscription with the DON. Make a note of your subscription ID so we can directly make requests through our subscription. We can now make an on-chain request where our JavaScript code will run on an entire DON as opposed to a single Chainlink node. We can copy this command, which will call our execute request function. Subscription ID is going to be 148 because we just made it. Our deployed contract address is right here. Network Mumbai. It's giving us the estimated cost in link. We're going to go ahead and run this. And we've successfully made a request, got a response from a Chainlink DON and stored it on chain. You can now code any JavaScript that you want. In your example here, you can make HTTP GET requests and have all the advantages of a Chainlink data feed. Good luck with this newfound power, and I'll see you next time.